I'm a wood technologist at the Advanced Structures and Composites Center at the University of Maine. We're looking at LP's Legacy OSB, and we're putting it through its paces. We're comparing Legacy to a commodity OSB product as well as a plywood product. We are simulating outdoor exposure, various moisture contents, and repeated floor traffic, and we're seeing how it stacks up.
If you're going to do applicable research that is relevant to these companies, you really need to try to simulate their processes to the extent possible. So we've made the investment here to be able to do that.
The first part of the project, we took Legacy OSB as well as commodity OSB and plywood, attached hardwood flooring to the subfloor. We did some staple withdrawal tests by pulling the hardwood flooring off of the subfloor. What we're looking for as part of that is the staple holding capacity of the subfloor. Fastener holding capacity is extremely important to structural panels because it's a measure of how well that subfloor retains the fastener. The finding from phase 1 with the Legacy OSB had a withdrawal capacity about 35% higher than the other two products. Phase 2 involved simulating a rainstorm. So it rained for 8 hours, then we dried it back down to its original moisture content and did that 2 more times. Phase 3, we were trying to simulate various moisture contents over time in a given home. We took specimens that were subjected to the previous wetting cycle, attached hardwood flooring to them, and then kept them in a conditioning chamber for close to a year. We did not see any significant dimensional changes with the Legacy OSB at all. Phase 4 is where it all comes together. We're simulating someone walking on that floor. We're looking to see if the floor squeaks, and then we're looking to see if withdrawal capacity of fasteners is reduced. After all of the exposures, the repeated wetting, the repeated hygrothermal cycling, and the repeated loading, the fastener capacity of Legacy OSB has virtually remained unchanged.